in order to convert between the mass of a substance that you've collected and the number of moles of it, you need molar mass, the mass of a mole. So to get that, you can look at the periodic table. So, on the periodic table, you can see that on average, a carbon atom has a mass of 12.01 AMUs. That's the average atomic mass of carbon. But it turns out a mole of carbon has the exact same number, 12.01 grams, instead of AMUs. That's the molar mass. The mass of a mole of carbon is on the periodic table, 12.01. But this is the molar mass of just carbon. What if you have something larger like a molecule of methane? So carbon might have an atomic mass of 12.01 AMUs, and each hydrogen might have a mass of 1.01 AMUs. So you can add all those values up to get the molecular mass. So the molecular mass is just the number of atoms of each element times their atomic mass on the periodic table. And then you add those up. So this is the mass of a molecule of CH4. But if you want the mass of a mole of CH4 molecules, then it's the exact same number, 16.05 grams, not AMUs. That's the molar mass of a molecule. So let's say that we have 0.48 grams of aluminum. How many atoms of aluminum do we have? Okay, so we have grams, and we want to get into atoms of aluminum. The representative particle of aluminum is atoms, so we can just go into representative particles here. But in order to do that, you need to go through the mole. We know the molar mass of aluminum, the number of grams per mole, and we know that there's 6.02 times 10 to the 23 representative particles per mole. So the only connection between mass and representative particles is mole. That's our rest stop, and you'll see that is our happy place in almost all calculations in chemistry from here on. Moles is going to be in the middle of your calculation. That's where the leprechauns prance about and the deer eat out of the palm of your hand. That is your happy place. Go to the land of the mole. So we want to go from grams to moles to representative particles. So first, convert from grams into moles of aluminum using the mass of a mole of aluminum. It's on the periodic table, 26.98 grams per mole. And then convert out of moles and into representative particles of aluminum. In this case, it is atoms because it's just Al. It's not Al2, it's not Al2O3. If it's just a simple element that's not a diatomic element, which we'll get to later, then the representative particle is atoms. So there are 6.02 times 10 to the 23 atoms per mole. And so 0.48 times 6.02 times 10 to the 23 divided by 26.98 is 1.1 times 10 to the 22. Now, you'll see that we started with 2 sig figs here, and then we divided by 4 sig figs and multiplied by 3 sig figs. And this 1 sig fig, this is not 1 sig fig. This is an exact number. There are 26.98 grams per mole of aluminum, exactly 1 mole. Anytime you see such a simple number like that, it's probably an exact number. It does not control the number of sig figs in your answer. Consider it to have infinite sig figs. So just ignore that for sig figs. We start with 2 sig figs. That's the smallest of the number of sig figs. We should have 2 sig figs in our answer. All right, next question. If we have 14.98 grams of calcium phosphate, how many atoms of calcium do we have? All right, so we have grams, and we want to get into atoms of just calcium. So having this compound here, not pure element, when we convert into moles and then into representative particles, that will not be atoms of calcium. That will be formula units of that ionic compound. So we'll need to do another conversion to get into atoms. So you have 14.9 grams of calcium phosphate. You were not provided the formula of that compound. Oh no, you have to write the formula yourself in order to be able to have the correct molar mass and the correct number of atoms of calcium per formula unit. So how do you write that formula? Well, calcium is in group 2A, it gets a charge of +2, and phosphate is PO4 3-. So crisscross calcium phosphate is PO4, well, Ca3, PO4 parentheses 2. That's calcium phosphate. That's how you got that. So you plug that in here. So now, to convert from grams of calcium phosphate into moles of calcium phosphate, you need the molar mass of calcium phosphate. On the periodic table, do 3 times 40.08 plus 2 times 30.97 for phosphorus, and 2 times 4, 8 times 16.00 for oxygen. And so that adds up to 310.18 grams per mole of calcium phosphate. And then to convert from moles of calcium phosphate into formula units of this ionic compound, you know that there's 6.02 times 10 to the 23 of that thing per mole of it. 6.02 times 10 to the 23 representative particles per mole. And then finally, you want to get into atoms of just calcium. So per calcium phosphate formula unit, there are 3 calciums. So there's 3 atoms of calcium per formula unit of calcium phosphate. So 14.9 times 6.02 times 10 to the 23 times 3, then divided by 310.18 gives 8.68 times 10 to the 22 atoms of calcium. So what we just did was we used the mole map again. We just went from grams, a unit of mass, all the way into atoms of a specific element, calcium. So we took the number of grams and we multiplied by this unit conversion factor, 1 mole over the molar mass of that substance. Then, to go further to the right, we multiplied by 6.02 times 10 to the 23 over 1 mole. And then to go into atoms of just calcium, we found the number of atoms of calcium per formula unit of that substance. The mole map is your friend. It pretty much shows you all the calculations that you need to do. Just follow the arrows. If you need to go from mass to moles, follow this arrow. It takes you to the right just by multiplying by this unit conversion factor. If you needed to go in the opposite direction, then you would multiply by the inverse of that. Instead of 1 mole over molar mass, it would be molar mass over 1 mole. It would get you from moles into mass, etc.